Okay, so this is the 2008 AMC12B problem 25. Let ABCD be a trapezoid with AB parallel to CD, AB equals 11, BC equals 5, CD equals 19, and AD equals 7. Bisectors of angle A and angle D meet at P, and bisectors of B and C meet at Q. What is the area of hexagon ABQ-CDP? So I've shown another diagram here, and what you might initially notice is that P and Q look like they might be parallel to AB and CD. So it would be nice if we can prove that, because then we would have two trapezoids, ABQP and BCQP, and then it would be much easier to find the area of ABQCDP. So let's try to prove that. Let's say we have any trapezoid ABCD with angle bisectors the same way as in the problem. Well, what do we know about an angle bisector in relation to the two sides that is sandwiched between? Well, the angle bisector is equidistant. Any point on the angle bisector, for example, let's just say this one, is equidistant from the two sides. So this means that this point P is equidistant from the side AD. But we also know that P lies on the angle bisector of angle A, which means we can also say that this point is equidistant from side AB. So what does this mean? This means that this point P is equidistant from both sides AB and CD. And we can use the exact same reasoning for point Q and show that this is also equidistant. And since we know that they lie, well, you can see that it lies on the midpoint between sides AB and CD. So points P and Q must lie on the midline of trapezoid ABCD. And if you recall the properties of the midline, the midline is parallel to both sides AB and CD, and it is exactly half their sum. So I'll just say these points are X and Y. XY is parallel to AB and CD, and XY is also equal to AB plus CD divided by 2. Okay, now what we need to do is figure out the length of PQ in the original problem. So we know that if we draw the entire midline here, well, what is this entire length going to be if we label these points XY? It would be 11 plus 19, which is 30, divided by 2. So XY is equal to 15. The length of XY is 15. And let's look at this angle here. If this has a measure of A, well, we know that the midline is parallel, so XY is parallel to CD. So by alternate interior angles, this must also be equal to A. But we also know that this is an angle bisector, this segment here. So this is also equal to A. And we have two equal angles, which means that these two segments must be equal. And similarly, we can do the same thing on this side. So this length PQ is going to be equal to the midline minus these two segments, and that's going to be minus 3.5 minus 2.5, which is the same as minus 6. So this is actually length of PQ. PQ is equal to 15 minus 3.5 minus 2.5, which is 9. Okay, now that we have the length of PQ, what we need to do is calculate the height of this entire trapezoid. Because once we get the height, we know that this length here will be h over 2, and so this length here. And then we can calculate the area of each of the two triangles individually, add them up to find the final answer. So how can we do this? Well, one approach is using a system of equations. So I'll redraw the trapezoid here because it's getting a bit messy. 11, 19, 5, 7. So we can draw the two heights. Since this part is 11, that means that these two segments must add up to 8, which is 19 minus 11. So we can say this is x, 8 minus x, and this is h, and this is also h. So we can use the Pythagorean theorem to get two equations for two variables. So we would have h squared plus x squared in this triangle here is equal to 7 squared, 49. Here we have 8 minus x squared plus h squared is equal to 25. Let's expand the second equation. X squared minus 16x plus 64 plus h squared equals 25. H squared plus x squared is 49. So we can get rid of these two terms, replace them with 49. 49 plus 64 minus 16x equals 25. 64 plus 49 is 113. So 16x is equal to 88. And x is equal to 88 over 16, I believe. Let's check the work. Yes, 88 over 16. And then we can use this to find h. You can just plug it into the original equations. So 88 over 16 is 22 over 4, or 11 over 2. And so we have h squared, I'll just write it here. H squared plus x squared is 49. So h squared plus 121 over 4 is equal to 49 times 4 is 36, 196. So 196 over 4. Subtract these two, we get h squared is equal to 75 over 4. And so h is equal to 5 root 3 over 2. Hopefully I'm not making a calculation mistake. Yeah. Okay. Now that we have h, we want to find the area of these two trapezoids here. So h over 2 is 5 root 3 over 4. And now what we have to do is just calculate the area, let's say ABPQ. 11 plus 9 divided by 2 is 10, times the height, which is 5 root 3 over 4. 9 plus 19 divided by 2 is 14. Times the height, 5 root 3 over 4. This is equal to 24 times 5 root 3 over 4. 6 times 5 root 3 is 30 root 3. And that is answer choice B. So I hope this solution makes sense. I think a lot of the solutions on the wiki use trig. So I just wanted to show another approach. Okay, I just noticed that the bottom part of the problem was cut off. So I'll just explain that part really quickly again. So I calculate the height, which is h squared plus 121 over 4 equals 196 over 4. So h squared is 75 over 4, and you can simplify that into 5 root 3 over 2. So h over 2, which is the height of each of these smaller trapezoids, is 5 root 3 over 4. And then you can just use that to calculate the answer to the problem.